Hey, today we're going to be talking about overtopping of earthen dams due to flooding. Now, I bet you are wondering, what is an earthen dam? Now, here in South Carolina, the most prominent earth dam is Lake Murray in Lexington County. An earth dam is made out of natural materials such as clay and sand. Now, the clay is usually used as the core that is surrounded by sand or gravel soils, which protects the clay and keeps the dam in its desired shape. Then the dam has spillway that is used to prevent the dam from overtopping. In South Carolina, we have approximately 2,387 states regulated dams, with the majority of them being earthen dams of various sizes and structure types. The one thing that remains the same for all earthen dams is that they are not designed to withstand overtopping. Earthen dams are designed using the rational method to find the probable maximum flood equation. This equation calculates the largest probable flood that could conceivably occur at the dam's location, estimated by the probable maximum precipitation. In the equation, the A stands for the catchment area of the dam. The P is the estimated 24-hour rainfall for the selected return period. R is the storm's depth ratio. CR is the runoff coefficient, and TC is the time of concentration. Overtopping is when the amount of water being held by the dam exceeds the amount it was designed for. The water goes over the top of the dam and goes down the opposite side, which is impossible to stop. Now, overtopping can happen for a couple of reasons. The first is when there is a flood. A flood is caused by a constant rainfall, and this spillway of the dam is unable to keep up with the flow of water. The water has no other place to go than over the top of the dam. Another cause of overtopping is the spillway is blocked by debris or has collapsed, and this does not allow for water to be steadily drained. I bet you are wondering, why is it such a big deal that the water is going over the dam? This is due to water causing erosion. Because the dam is made of earthen materials such as sand, the water hitting the opposite side of the dam is not made to withstand the water flow. This relates to the dam structure to be compromised. Once the water begins to erode, the protective layer of soil does not stop. The core could be exposed, and once that happens, the dam typically breaches and washes away. Adding another layer, such as vegetation or gravel, to the back of the dam can slow down the erosion process. This allows the water to flow over and not disrupt the soil. However, this does not stop the erosion process completely. We will be doing 3 different simulations to demonstrate the overtopping process and how different top layers affects the speed at which it occurs. The dam we'll use in these simulations will have a clay layer. Ours will be made out of Play-Doh, surrounded by the sand. In this first simulation, we will use grass to disrupt the flow of water. In each simulation, we will compare the amount of time it takes for the dam's core to fail as a result of overtopping. In all of the simulations, we will assume that it is raining consistently for an extended period of time in order to cause substantial flooding. The second simulation will include a layer of gravel over the backside of the dam. In theory, this should preserve the dam's core longer than the grass can. The last simulation is of a dam constructed with just clay and sand layers. Thank you for taking the time to watch our video, and I hope you enjoyed learning about the overtopping of earthen dams.